Shortly after the spring 2026 semester ended, I was scrolling through Reddit and saw people talking about CS10, Berkeley's Intro Computer Science course for non-majors. Apparently, the class had an unusually high number of failing grades. Around the same time, a news article from the Daily Cow covered the situation. The article reported that some students had been caught cheating on take-home exams, and the instructor suggested that other students who relied too heavily on AI tools were unprepared for exams. But what confused me was that a huge part of CS10 uses Snap, which is basically a more advanced version of Scratch, like literally drag and drop block coding. So naturally, I had one question: can AI actually write Scratch code? In this video, I'm going to test whether AI can write beginner Scratch code, build actual games, debug broken projects, and maybe even pass a Scratch programming class. Quick disclaimer: please do not try this on actual assignments or exams. This video is purely for educational and entertaining purposes, and I'm not responsible if you submit AI generated work and get caught. Cheating is an insane way to throw away your GPA. So why does this matter? AI can already generate code in languages like Python, Java, and C++, but Scratch is different. Instead of writing code line by line, you're building programs by connecting visual blocks together. Even though Scratch looks completely different from traditional code, it still follows a structured format behind the scenes. Every sprite, block, and connection is stored in that file. So technically, AI should be able to understand block code, but whether it can actually build good projects is a different story. Let's find out. I uploaded the Scratch project zip file to Claude, and I'm going to start off with the most basic thing, which is make a sprite move with arrow keys. Alright, nice. I'm going to download it and see if it actually works in Scratch. So here's the code that Claude generated. It looks right to me, like when the up arrow is pressed, change Y by 10. When the down arrow was pressed, change Y by -10. When the left arrow is pressed, change the direction and change X by -10. When right arrow is pressed, change the direction and change X by 10. Let's see if it actually works. Okay, nice. I thought I needed to do multiple prompts, but it looks like Claude got it right on the first try. So AI can create basic movement, but can it create basic games? And that's the next challenge, which is to create Pong in Scratch. This time, I uploaded an SB3 file to see if Claude can understand it. Anyways, here we go. Alright, looks like it's done, but take a look at this. There is a lot of thinking that went into building Pong in Scratch. But anyways, let's see if it works or not. So here's the code that was generated, and it looks like there are 3 sprites: the left paddle, the right paddle, and the ball. The controls for the left paddle is W and S, and the controls for the right paddle is up and down arrow. And let's see if it actually works. Okay, it looks like it worked on the first try. I thought that because it's a game, it would need multiple attempts for it to actually work correctly. The real question is, can AI pass an actual assignment from the class? Unfortunately, I cannot just take a CS10 project and throw it into AI. The academic integrity policy does not allow sharing solutions or copying code from online sources. So instead, I made my own assignment that tests the same programming concepts. The assignment is to create a tic-tac-toe game, and let's see if AI can build it. While that's generating, I'll be grading it on 4 things. Functionality: does the game actually work? Readability: is the code organized and understandable? Bugs: how many issues show up during testing? And finally, if I were a TA, would this immediately look AI generated? Alright, here's what Claude generated. Now let's load it into Scratch and see if it actually works. So here's the game, and the first test I'm going to do is to tie the game. Okay, I don't have my headset on, but I like how it makes a sound when the game is over. For the next test, I'm going to make X win. Now for the final test. I'm going to make O win. Okay, so it looks like the game actually works. So the score is 10 out of 10. Let's see if the code is organized and understandable. So right now I'm on the grid line sprite, which basically creates the grid. And it definitely looks organized and understandable. And the code is also correct. So here's the cell sprite. It's a lot of code. I think it's a little bit disorganized, but at the same time it's also understandable as well if you go through everything. And the final sprite. It's simple code, so it's definitely organized and understandable. In terms of readability, I would score this a 9 out of 10. In terms of bugs, I did not see any. And honestly, if I was a TA, I would not think this is AI generated. This is probably what students would actually use AI for, to debug broken code. So here I have a project with broken code, and let's see if AI can debug it. Looks like all the bugs were found. Let's see if Claude can fix it. Now let's see if all the bugs were fixed. Okay, I'm gonna click the green flag and see if it actually works. Okay, it looks like the bugs are fixed. But one thing it should do is that when the timer is below 0, the cat should stop moving. Okay, so here's the prompt I'm going to use. Looks like it's done. Alright, let's see if it works. Cool, it works. So, can AI actually write Scratch code? Technically, yes. But the bigger question is whether students are actually learning when using it. Even when students know that AI can hurt their learning, they still rely on it because it's fast and convenient. It explains concepts, fix errors, and generate code instantly. The problem is that beginners can end up using AI as a replacement for thinking, rather than as a tool to help them learn, making it harder to solve problems on their own. And that's why beginner computer science courses are vulnerable, because the assignments are smaller and more clearly defined, which makes it easier for AI to complete. But the purpose of these courses is not just to write code, it's to learn how to think, debug, and solve problems. That's why courses like CS61A have oral exams, where students have to explain their code to a TA and demonstrate that they actually understand what they built. And that is all for this video. Leave a like and subscribe. If you want personalized computer science or college advice, or just a chill place to chat, join my Discord server. Link in the description. Thanks for watching.